Hi, my name is TJ Rogers. This is Jim Davis. We're from Cypress today. Cypress announced its easy-to-use RF kit. So I challenged the apps engineers to make it easy to use in my winery. So this is a smoke test, hopefully not real smoke. I went into marketing, got a bunch of first touch kits. This is the one that got offered today. And the demo we're going to try to do today is use these first touch kits, attach them to the equipment in the winery to monitor the temperature of a tank and a chiller, and then instrument the barrel room, which is currently not instrumented, to real-time monitor humidity, temperature, pressure, and then take all of the data by radio and put it in this computer. And it's now 10:30. And I've got 2 hours to get it done because I got to get back to work. So we'll find out if this stuff is easy to use or not. So here's my computer. Here's a first touch kit. To save time, I've already loaded up the software back at the factory. And we'll see if I can get my screen up right now. So it says sense and control, so I know that's what I want. Okay, there it is, sense and control. Now, it says clear current configuration. I want to do that because I was messing around with it first time back at the plant. Continue on. Now that I got it clear, software is loaded up. Take out my kit. So I got a little battery pack. I've got two kinds of batteries. I've got the coin cell if I want a really small, lightweight device and want to demonstrate that. In my case, I'll just put in normal AAA cells in a little battery pack. The thing is designed not as a production product, but as a demonstration capability. So in this case, here's the radio board. So I'm plugging it into the battery pack. And today I'm going to look at a thermocouple. So this is one of the adapters you could plug in to do a thermocouple. This is a first touch adapter. There are multiple adapters that you can put in. I'll show you a couple of them today. All right, so I've hooked the thing up. So this is the radio. And to hook the radio to computer, I've got a dongle. It goes in the USB port. If you want, you can plug it in with an extension cord. I'll just plug it straight in. So that takes care of that. When I plug it in, I see a blue light. That means I've got it. I'm looking down here for the machine to find it. So now I want to connect up my radio, and actually might as well hook up a live thermocouple. This is a thermocouple, stainless steel, that you put in wine to measure temperature. And it comes with a standard thermocouple plug to it. And I'll just hook that up to the radio. I brought a couple thermocouples. A thermocouple is nothing but a wire that's been welded, two different kinds of wire, and they produce a slight microvolt level voltage between them. And they all come on a standard plug, so you can buy these pretty much anywhere. Almost all temperature measurements in industrial space are made with thermocouples. What I'm going to try to do later is hook up these thermocouples to measure some stuff in the winery that would cost me literally $1,000 to measure. Okay, so as a matter of fact, instead of hooking up this big one, why don't I just hook up one of these small ones? Doesn't really matter. So here's a radio and a thermocouple, and it's time for me to hook it up. So I know that I want to add a node. So then it tells me to step 1, begin binding. Binding means connecting the radio to the dongle. So I hit a button and it gives me 20 seconds.
You also have to flip the on switch on the battery pack.
I've got to turn on my battery. And I hit the binding button. And it happens. So when that ID number comes in, I've bound. And I was going to ask, what do I do next? That's why there's that next thing there. Then it comes back and it says, give it a name. So I'll call it TJR space TC1, and I'll use it later. And then it says load the node configuration from a file. In other words, I want to tell it what it is, so I'll hit that. And then I'll look at all the things that are on the file. These are all on the software you get. And in this particular case, I've got a thermocouple. So I've loaded it up. Okay, so there's my thermocouple. And as you can see here, the temperature is 19.9 degrees centigrade. Well, 19.8, then it jumped to 19.9. You can see 2 data points. There's 3 data points. The radio is currently set to send in a data point every 5 seconds. So for the sake of demonstration here, the way you've changed this is you press this button. Press this button and hold it until a red light shines. Then it'll change to a different frequency. That's 10 seconds. Then it'll change again to what, 30?
30 seconds.
Then I press it and hold it until I get a red light, and then it changes to a minute.
That's correct. That's actually the 5-minute one. So
5 minutes. Now I'm going to do it again, and it cycles back to 1 second. So now I've changed the radio so it's going every 1 second. So now you can see the data coming in here. I wouldn't do that in real life. I don't need temperature data every second, but you see it happening. I'll put my finger on it to heat it up a little bit, and there it goes, taking off. You can see the range will automatically change here. So what happens, there's 36 data points here. What happens when you get more data than you can handle? Well, you can compress the data. So I want to do that. Let's see if I can remember that. Configure, calibrate, chart. That makes sense.
So you have to select the sensor first.
Oh, select my sensor.
Just clicking on the graph.
Oh yeah, I got to do a click here. Okay, now I do my chart. That is, I'm going to operate on what the chart does. All right, let's see. I don't care about the label, it's fine. Let me put in an alarm for now. Let me put in an alarm. See, right now I'm running as high as 23 and as low as 18. So let me put in a high alarm of, hit that first?
Yes.
Put in a high alarm of 24, maybe 25. And I'll put in a low alarm of, oh, let's say 16. It looks like it's getting pretty cool in there. Okay, now you see I've put in alarms. So I've got a high alarm and a low alarm. Over here is the alarm history. So what I'm going to do is put my finger on the thermocouple and heat it up. I hope I'm warm enough. This room is pretty cold. I'm going to heat up. You can see the data coming in hotter every second, and pretty soon it'll get to the alarm level. And then we have an alarm. You can see the alarm over here. So if your data goes in the wrong direction on you, you can come back later. Okay. Now the alarm is stopped. Now, you only get 36 data points there, and that's only 36 seconds worth of data, and that's really not that useful. So what I want to do is I want to have the radio compress the data so I can look at a week's worth of data, for example, but I don't want to lose my real-time data. So we've got a chart in there, so you can, I have to click on this first, right?
Correct.
And then I click chart. Okay, that's where I put my alarms on now. It says enable short-term aggregation interval, enable long-term aggregation interval. I'm going to do both. An aggregation interval is just that. So now, instead of looking at the data every second, I'll do it still frequently so you can see it on this tape. I'll do it every 5 what? 5 seconds. And I'm then going to enable the long-term aggregate label, and I'm going to do it every 10 seconds. I know that's not what I do normally. In a real industrial situation, this would be every hour, and this would be every 24 hours. And then I could store a day's worth of data here, and I could store a week's worth of data here. But for this demo, I'll pick let's see, 10 seconds. In this case, I'll just do it the old-fashioned way. There it is. Now I apply that, bam. So now you see up here what happens. There's my 12 seconds worth of data coming in there, or in 1 second at a time. There's 5 seconds worth of data, there's 5 seconds worth of data, and you note that the 5 seconds worth of data is a line, and you ask yourself, why is it a line? And I'll show you in a minute what it really is. It's all collapsed, you can't tell it. So now you can see. So what this data is the maximum and minimum, and the box represents the 25th, 50th, and 70th percentile point. So when this data goes through an excursion here, these data aggregates of 5 seconds each show range, and these data aggregates of 10 seconds each show another range. Now, in my real winery, I'd have this be every 15 seconds, so I'd have a long battery life. I'd have this be every 12 hours or half a day. So then I'd get 12 data points here, 6 days worth of data. And then out here, I'd make it a day. So I'd get 12 days worth of data. So I can walk in and see what my temperature was 1, 2, 3 seconds ago, what the maximum, minimum, and average temperature was during the last day, and average, minimum, maximum during the last week. So there's my temperature being recorded real time. I'm actually interested in taking this one outside and see if it'll go through a concrete wall. So what I've got here is just some PVC pipe, and I'll take my battery and my radio and put it in the pipe. And I'm not going to glue this, but I could glue it and put RTV on it to make it waterproof. And here's my thermocouple. Now what I'm really interested in looking at is a machine I have outside that's a pain in the butt, and I have to go outside all the time. So what I really want to do is just take this thing and put it outside forever and be able to read my temperature inside. So that's what I'm going to try to do right now and see if it continues to run. The water is 4 degrees centigrade in there. So let's go in and find out if we're monitoring this machine. So we'll see what we've got, and there it is. You can see that the temperature is now looking at about 4 degrees centigrade. We're getting a continuous stream of warnings because we're below the lower limit. I'm going to change it, but now I'm monitoring that outside temperature through a 1 foot thick concrete wall. Let's see, my chart. I want to bring that down, and I want to take my lower alarm limit. I want to change it to 0 degrees centigrade. What do I need to do? Backspace it out of here?
Just double click in it.
Double click, yep, and I do 0, click, and there it is. So now my new alarm is down at 0. So now my alarm is at 0. My temperature is at 4. Now I want to do my upper alarm also again, because it's a chiller. So bad is when you go too high. So let me set an alarm of 6 there and apply that. So there it is. I've now got a control loop. Now this is a very boring graph. It's a straight line, which is exactly what should happen. But basically there I am controlling at 4, looks like 4.3 degrees centigrade. I'm in the control limits. If it goes above the control limit, I'll start getting warnings over here. Obviously an engineer doing an application on this thing could, for example, turn that into an email and send somebody a warning that temperature is wrong. What I want to do now is I want to just put in a second thermometer to show the ability to monitor actually, let's put in 3 thermometers. So that chiller chills the wine tank, and the wine tank in turn chills the wine. So let's find out what the temperature of the wine jacket is and what the temperature of the wine. It's not wine yet, it's just grape juice sitting there soaking. So let me do a couple more thermocouples. I'll do another one of these, which I can hook up to the tank. And then I'll do the food grade thermocouple, which I can hook up to the grape juice. In this particular case, I would normally put the electronics in a more fancy way, but right now this is an insulating jacket, and underneath the insulating jacket is a cooling jacket. So basically I do a better job on that. So this one's been cleaned. You can get a picture here. I'm going to shove this thermocouple into the wine, and I'm going to leave that there for a while. Also, I'll be informal on where I put this stuff. I tie it down better in the winery later. So now I've got thermocouple 2 monitoring jacket temperature, which is driven by the machine outside. I've got thermocouple 3 measuring the wine temperature. And I can come in here and I can see that my outside water is at 4 degrees centigrade, 4.3. My jacket temperature looks at about 10. It's not quite stabilized yet. It's, let's see, yep, there it is. It stabilized. It's about 10 degrees centigrade. And the wine is also at about 10 degrees centigrade. So the wine is at the same temperature. Now, I can alarm all of these. I can put alarms on each graph. So let me do, the wine is what matters. Right now we're doing what's called cold soak, and that means I'm trying to keep the wine as liquid grape juice for about a week. Soaks out color and flavor without alcoholic fermentation. The bad thing here is that the wine gets too hot and starts to ferment, and I don't know about it. So I'd put an alarm on here. So let's see. I want to click on this graph, and I want to work on the chart. And I want to put in a high alarm only. I don't care about a low alarm. And basically, if that wine gets hotter than 12 degrees centigrade, I want to know about it. So there's my alarm right there. So in this case, I'm taking data every 5 seconds, so you can see the transient that's gone through. And the tank, if it gets hotter than 12, will alarm me, and it'll show up over here. Now sometimes you want to have a lot of temperature sensors, and there's a different way to chart. Is that chart? Jim, I forgot. Chart.
So you click on the one that you want to change into a text? Is that what you're referring to?
Yeah.
And then click configure?
Configure. Okay, so now there's another thing I can do here, configure. And basically
and then
it
sensor
says
display options.
graph sensor textually display. So I'm going to show you the other way of doing it. And this sometimes is better, so that's all I want to do. I want to apply that. And there it is. And let me go click on this one and do the same thing. So I'll click on this graph, and I'll configure it. And I'll take it over to be a text as well. And I'll apply that. And now I got my nuclear dashboard, as I like to call it, where I can have a bunch of these on a page. So now you can see thermocouple 1, I could label that outside water as 4.5 degrees centigrade. The tank is at 8.1, and the thermocouple is at 7.4. Now the fact is that internal thermocouple, that big long stainless steel one, has been calibrated perfectly, and I know it's accurate. That means there's an inaccuracy in this thermocouple. And I know this thermocouple should be the same temperature as that one, so that's my calibration. So
You want to click on the sensor you want to calibrate first?
oh yeah. Okay, so I want to calibrate this guy right here, so I click on it, I get the box, and I want to calibrate. All right, so
Now you have both sensors visible as you add a...
yep, add point. So I'm going to add a calibration point. I'm calibrating the one I've highlighted here, so I'm going to add a calibration point. And the raw value is 8.1.
Correct.
And the adjusted value should be, the calibrated value should be 7.5. And when I apply it, bam, I'm calibrated.
And then click apply one more time.
Click apply one more time, and there it is. So now those two are exactly calibrated. There's an interesting other thing about calibration, and that is it says add a point, you can do another point. This is a 1-point calibration that made that thermocouple exactly accurate at 7.5. If I wanted to make it exactly accurate between 0 degrees centigrade and 100, between freezing and boiling, I could put in 2 points, and then the calibration would be a line. I could actually put in 10 data points and the calibration would be a least squares line. So the calibration can be a single point or multi-point. That's all available in the software. I want to do one more thing which is cool for a winery. And I want to do a weather station. In a barrel room, you're interested in temperature of the barrels and you're interested in humidity. A barrel room should be humid and cool, ideally 55 to 60 degrees Fahrenheit, and it should be about 70% relative humidity. So I'm going to actually use a special sensor that you can get, and I'm going to instrument the barrel room. Is the last thing I do here this morning. This is our barrel room here. So here's where we're currently storing Claude Latec, and I guess as good as place of any is just to put it right in the barrels. The metal won't bother it. I'll set it right there for now, and we'll see what the barrel room looks like back on the computer. The barrel room temperature is about, see, now we're down to 0.05 degrees centigrade, so it's very, very stable. And pressure really doesn't matter, but that's on the weather sensor. So here you are looking at a wired winery. We've been working for 2 hours. I had exactly 30 minutes of training on this stuff, as you could tell, because I needed a helper here. But I now have the most expensive piece of equipment with real-time statistical monitoring on it. And I've got 4 different measurements coming out of my barrel room. And I wired my winery. I guarantee you, if you brought in a union electrician, this would have taken a week and cost $50,000 bucks. So that's the new RF kit. Thank you.